Okay, pumpkins, it's Friday afternoon. Let's see how we can do this. Let's see how well this is. RedOx. Everybody's favorite unit. Some people love it, some people hate it. Okay, what do you need to know? I'm going to focus mostly on the cells for this, but I will include some regular RedOx stuff. You can probably bet you're going to have a Voltaic cell or an electrolytic cell on your part 2, so make sure you know that stuff really well. For the sake of being different, let's start with an electrolytic cell. An electrolytic cell is in one chamber. Okay? There's one. There's no salt bridge. No salt bridge. I should have calibrated this first. Too bad. You still have 2 electrodes. Doesn't matter really what they are. Sometimes you'll have like a spoon. Let's say that's a spoon, shall we? Sometimes you'll have a fork, a key, who knows what, okay? The idea here, I'll connect them, is that they are connected and that you're going to plate onto the spoon or the key or the cathode, okay? This is an electrolytic cell. So here's your battery. Actually, I am going to calibrate this, so please stand by. Okay, that's better. So you have a battery or some sort of power source. What that means is that this electrolytic cell, you have to put energy into it. If energy goes in, it's endothermic. Additionally, you're taking the electrical energy, and I can't spell electrical at this hour on a Friday afternoon, and you're converting it to chemical energy. You are forcing a reaction to happen that wouldn't normally happen, okay? I gave you all this analogy that an electrolytic cell is similar to charging your cell phone. Your cell phone battery operates like it normally does. It runs your cell phone, and then when that's like a voltaic cell. When the reaction reaches equilibrium, then you have to plug it into the wall or a power source and force the electrons to go away that they do not want to go. The anode is the thing that is not the key or the fork or the spoon. You can generally tell it's the anode because it's the positive. They will tell you it's positive. And the anode in this case, the case of an electrolytic cell, is positive. It's on the positive terminal of the battery. That means that the cathode is negative. That should make sense. Electrons do not want to go from positive to negative. Electrons are negative. They're repelled by the negative. Okay? However, electrons always flow anode to cathode, no matter what type of cell it is. The big difference is the positive and the negative here. What happens at the anode? Oxidation. Doesn't matter what type of cell. Oxidation happens at the anode. That means electrons are lost. Leo the lion says, grr. So electrons are lost during oxidation. This is electron flow. This threw me off. I will put that in a little bubble so that you know that this is not the anode, this is the cathode. So, reduction happens at the cathode, and electrons are gained here. Please, 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 electrons have no mass as far as we are concerned. Their mass is so tiny that it doesn't matter. Why does the cathode gain mass? It's not because it gains electrons. It's because the ions in the solution are reduced. They're usually metals. They're always metals as far as we are concerned. They're reduced onto the cathode. So they turn into silver solid. These atoms, these ions that are being reduced are what's adding to the mass. Okay? The anode loses mass because the anode is being oxidized. So it's turning, metals like to be oxidized, right? Metals like to lose their electrons. So it's turning from a silver solid into silver ions. All right. You've got the electron flow. You've got the oxidation reaction, you've got the reduction, anox, red cap. The reaction at the anode, silver is being oxidized, so it turns into silver plus. That means it loses an electron. On this side, it's reduction. That means silver is being reduced. You can't reduce silver. You have to reduce silver plus, because metals do not go negative. Metals like to lose electrons, not gain them. There's your other reaction. That's an electrolytic cell. A voltaic cell is probably a little bit more common, what you will see. Not a ton, though. Voltaic cell. Voltaic cell is a battery. It does not require a battery, but it is a battery. Okay? What that means, what does it look like? The chemical reactions in many batteries are very similar to the ones that we've talked about. You have two chambers for a voltaic cell. Here is an electrode, here is an electrode. You have two types of electrodes, anodes and cathodes. The anode is not always on the left, so in this case I'm going to put the anode on the right to switch it up. So let's say that this over here is silver, and let's say that this over here is lead. If I gave you that much information, you should be able to tell me what is the anode and what is the cathode using table J. The higher one on table J is the anode. That means it's oxidized. Okay? The more popular one gets its way. Metals like to be oxidized. So we have the anode. Look at me writing anode with only one N. I'm so proud. And the cathode. Electrons still flow through the wire, and they still flow from anode to cathode. Okay? They always go anode to cathode. The anode is still where oxidation occurs, and the cathode is still where reduction occurs. Okay? So the anode still loses mass, not because it's losing electrons, but because it's being oxidized. So it's going to lead, let's say +2 in this case, and this is essentially losing the lead solid that's on that electrode is going into the solution. There is a liquid there. And then the cathode is being reduced, so the cathode increases in mass, not because it's gaining electrons, but because the silver ions in the solution are reducing onto the electrode. Okay? They are sticking to the electrode. We can actually do when I was in high school, we actually did a lab with this and actually could measure the mass gained by the cathode, which was pretty cool. So you can actually measure it. It's not just electrons, it's actual atoms that are going on there. Electron flow, like I said, is anode to cathode as always. The difference here is that the cathode is positive and the anode is negative. An anion is negative, so the anode is negative in a spontaneous reaction. The cathode is, a cation is positive, so a cathode is positive as well. What this is missing is our lovely salt bridge. It is not a bridge made of salt, it's a bridge with ions in it, ions. What that means is it prevents polarization of these cells, okay? We have electrons, we have negatives going this way, going from anode to cathode. So if we keep adding negatives over here, we end up building up positives and we end up building up negatives. And real life does not like polarization of charge. They do not like to have a charge. Everything likes to stay nice and balanced, okay? So this salt bridge prevents that. It allows ions to travel. It does not allow electrons. Electrons go through the wire, okay? So here we have reduction. It should be a reduction equation. It should be silver plus an electron turns into silver. And on the other side, we should close our electrode, and we have an oxidation equation, which is lead turning into lead +2 and 2 electrons. Now, if I were to combine these two half reactions into one whole reaction by adding them together, I would need to make sure that my electrons lost are equal to my electrons gained. So my electrons lost from lead over here are equal to my electrons gained by silver. So I would need 2 silvers to balance that out, so those electrons cancel. Your overall reaction would look like 2Ag plus Pb gives me 2Ag plus Pb plus 2. Okay? Remember that mass, charge, and energy are conserved. Okay? This one is spontaneous. This happens automatically. Spontaneous. And what else do I need to tell you about this one? This one is chemical energy to electrical energy. Okay? Chemical to electrical. Those are your two types of cells. Remember, charge and mass have to be totally conserved. We've got two positives over here, two positive ones, and we have two positives over here. So charge is conserved, and we have two silvers, one lead, mass is conserved. So double check